Assalamu alaikum. So this is going to be the second um, part in our probability series. Yeah, okay, we're done now. Now look. So in the last lesson we learned this stuff, right? Obviously I'm not going to repeat any of that. Now again S1, A2, just the basic things that we normally write. And today we are going to be taking a look at when do you plus and minus probabilities, right? And yep, that's going to be the second part in our series. Now look. Let's say, let me give you the example of three red balls, right? And just so that I can flex that I have got stylus, I'm going to change colors now. And four green balls, okay? And I'm going to just write with this. Yeah. Never mind. You know what? Let me just change the color real quick. We'll just go with dark green or this, right? Sorry for the time wastage though. Yep. No. Never mind. My bad. Now look. So you've got three red balls and four green balls, right? Inside of a bag, right? Inside of a bag, you've got all these balls, right? So now, if I was to ask you how many total outcomes are there, you would say four, five, six, seven. Seven are the total outcomes, right? Now let's just do simple probability. The very first event, the probability of which we have to find is event A, let's call it, is, let's say Amanda picks up a ball from the bag, right? The event is, look, that's just the story, okay, that Amanda is picking up what and what not from the bag. The event is, this keyboard is way too irritating, never mind. Okay, so event A is she picks up a red ball. Okay, red ball. She is going to pick up a red ball. What is the probability that the ball she's going to pick is going to be red? Okay, so the way we are going to do this question is just let me just. I think that's better, right? Okay, so the probability of event A would be how much? What are the total outcomes? Five. We got ourselves a denominator, right? Now we need to find the probability that the moment she puts her never mind puts her hand inside the bag, right, and then she takes out a red ball. What would the probability of this event? The total outcomes are seven. We wrote that in the denominator. The red balls, how many red balls are there? Three. So we're just going to write three in the numerator. The reason being this is the number of favorable outcomes, right? Just like we did in the case of a dice, right? If I was to do it this way, you've got the first red ball, the second red ball, the third red ball, right? And then you've got four green balls. So I can say 1G, 2G, 3G, 4G, and 5. Yep. Now look, how many favorable outcomes are there? Three of them. So it goes here in the denominator, right? And the total outcomes would be seven, so I wrote it here. This is the simple probability thing that we normally do, right? Now let's say the examiner, now we're also going to try to apply everything or most of the stuff, the main stuff that we have learned in the previous probability class, right? So let's say the examiner asks you, Amanda puts her hand back in the bag once again, right? Or look, let's just not say she puts her hand back. Okay, let's just reset the scenario. Amanda puts her hand inside the bag, right? What is the probability? Let's say event. Oh, sorry. Never mind. Look, I apologize for my writing. This is just the way I write. Okay, my writing is hideous. I get it. Okay. So event EVENT, never mind. Event B, let's call it, is she picks up a green ball. green ball, right? She picks up a green ball. What would be the probability of this? No, look, you can look, there are two ways of doing it. One is the manual way, thinking that the first question does not exist. We're just going to focus on the second question. The probability of this would be simple. That would be 4 over 7, right? It makes sense. Why? Because, I mean, there are 4 balls and the total outcomes is 7, right? It makes sense. That's method 1. I'm just going to write M1 over here. The second method would be, notice one thing. Event B is actually a complement of event A, right? If I write it this way, event B is equal to the complement of event A. Because if it's like the examiner is saying Amanda puts her hand in the bag, find the probability that she's going to find any other ball except a red one, right? Except a red one. So it kind of does make sense to say that event B is actually the opposite of event A, right? In that case, what can you do? The probability of event B is just going to be equal to 1 minus the probability of event A, right? You can also write it this way if that makes more sense. This is exactly the formula we learned in the previous class, right? If I show you, here we go. We learned it in here, right? So the other way of finding this would be probability B is just equal to probability A complement is equal to 1 minus probability of A, right? That's an A. I know it's hard to believe, but it actually is an A. Let me just rewrite it. Okay. In that case, the answer is going to be 1 minus 4 over, oh, sorry, 1 minus 3 over 7, and the answer is going to be 4 over 7. We get exactly the same answer, right? Now look, in this kind of a situation, we could have applied both of the methods, right? But in some situations, using the first method or the manual method, the normal method would become way too long, right? And when the clock is ticking at you, and like you're in under extreme exam stress and that kind of stuff, in that kind of a terrifying scenario, you should try to be more professional, or rather be lazy and just subtract it from 1. That is a better method in that kind of a situation. Both of the methods work out, but what you should use depends upon the kind of situation you find yourself in inside an exam. Okay, that's one thing. Now look, this is a simple example that I've used. Okay, I'm going to try to keep my writing a bit more clean now. Now that I realize it's way too ugly. I knew it was ugly from the very beginning, but maybe it's getting way too ugly now. So now we're going to discuss the plus and minus thing. Or, if I should write it as or, and. Okay? Now look. Let's say the examiner, you know what? I would rather do it this way. Let's just copy this entire thing. Copy. How do you paste it though without me using my mouse? Yeah, there we go. So we have got the thing. Now look. Let's say the examiner says, again, I'm not going to write it again. I'm just going to tell you, Amanda is putting her hand inside the bag, right? The event now is, let's call it event C, right? We're soon going to run out of letters to denote these events. So event C would be, she picks up a red ball or a green ball. No, look, this is the new thing. Why? Because we are being given two conditions inside one event. No, look, remember one thing. Every time you're given more than one conditions inside the same event, both of those conditions or all of those conditions, if there are going to be more than two, all of those conditions are going to be connected to each other in some way. They're either going to connect it using or they're going to connect it using an and. Okay, we're going to do the same question. Once we're at first we're going to do it with or, and then we are going to do it with an and, right? And then we're going to end this, session. Now look, every time you see yourself with an or, you plus the two probabilities, right? You add both of the two probabilities. What I'm trying to say here is that now look, every time, instead of being confused in this kind of a situation, try to find the probability. Now look, the simplest way to tackle this kind of a problem is first find the probability of condition one, right? And then find the probability of the second condition, right? Now, what are you going to do with the probabilities of both of them? We're going to look at it later, right? But just to keep it simple, what do? We try to find, the probability of each condition one at a time. Okay, so let's find the probability of this. She picks up a red ball. That's actually event A. We've already found it, right? We don't have to do it again. That would be 3 over 7. And the probability for this is 4 over 7. Okay. Now that we already had the probabilities, or we had to find the probabilities of both of the conditions separately, now we are going to find the probability that she picks up a red ball or a green ball, right? So event C would just be 3 over 7 plus 4 over 7. It's literally this simple. Okay, that would be 7 over 7 is equal to 1. That is actually the total probability. It doesn't normally happen in exams that, that the probability you're going to find is going to be 1. Why? Because if something is, you're sure of something, then there is no point in trying to find the probability. I've not seen an answer having 1. The only reason I have this answer is just because maybe I'm too dumb to make the right examples, maybe. Never mind. You better not try to call out me on my examples, okay? They're the best ones. So, yes, you just add both of them, right? It's kind of like probability C is just equal to the probability of A and B, and you add both of them, and you get yourself the answer. Okay, it doesn't always have to be 1, though. The reason being, every time you... Now, look, we have already seen what do we do every time we see an or, right? I'm not going to write right now. I'm just going to start yapping now, right? Let's look at why do we do this. So when every time inside an event, inside one single event, you've got yourself um, more than one condition, they're going to be connected by each other, right? It's either going to be connected by an or it's going to be connected by an and, right? By an and. In case of an or, all that you've got to do is find the probabilities of all of the conditions separately and then add them. The reason being, it's like they're giving you different scenarios, and then in order to find the total probability of all of the scenarios, you just add them up. This is kind of like, the universal rule. You can think of it this way, a simple universal rule. Okay? I'm going to say it again. Every time you've been given more than one condition inside the same event, you just find the probabilities of the individual events, and then you add them. If all of the events are connected to each other using an or, right? It's like in other words, if you want to find the total probability of multiple scenarios, right? Of multiple scenarios, then you just find them, then you just add them all together. It's just this simple, right? Or if I was to put it in another way, I can say it this way. When you want to find the total probability of multiple events connected by an or, then you just add all of them together, right? And that kind of becomes another event in and of itself, right? If any of this is confusing you, just remember, the simple thing. You've got an or, you add the probabilities, right? Now look, let's say Amanda puts her hand inside the bag, right? She picks up a ball, right? And then she puts her hand inside the bag once again. And that gives her another ball, right? Now comes I would rather call it the linear law. This is not exactly how you talk about it, but this is just what I'm going to call it now, right? Now the thing with and is a bit different. You see? The reason being, every time Amanda is going to put her hand inside the bag, right? What she needs to do is, or what we need to know is whether, whether the fact that she's going to put her hand inside the bag is happening with replacement or it's happening without replacement. Okay? Now look, let's say Amanda puts her hand inside the bag, she picks out a ball, right? And then she puts her hand inside the bag and then she picks up another ball, right? And it's happening with replacement. With replacement actually means that she's going to put her hand inside the bag. She's going to, take out a ball. With replacement means she's going to put it back in the bag and then she's going to pick up another ball, right? She's going to pick up another ball. This is what it means. So let's do it with replacement for once. Question is, event would be, let's call it X. She picks up a red ball, right? Then puts it back. Then picks up another ball. Okay? Then she picks up another ball. How are you going to do the probability? Now look, this is how I do it. This is how I used to do it in the exams. Okay? So let's say, now look, there are two scenarios. Sorry, that was not an event. This was, there's the general thing you need to know before a question begins. The event would be she picks up a red ball and a green one. Now look, you've got two conditions inside the same event. We're going to call this event X, right? You've got two conditions inside the same event, right? You've got picking up a red ball and then you've got yourself picking up a green one. And both of these conditions are connected by an and, right? So in this case, this is how you do it. There are going to be two scenarios in total. Maybe she puts her hand inside the bag and she picks up a red ball, right? And then she puts it back and then she picks up another one. She gets herself a green one, right? This is the first scenario. Another scenario is, now notice I'm going to write or. Why? Because there are two scenarios in here. Maybe the first ball she picked up is red and the second one is green, and maybe the first one she picked up was a green one and the other one she picked up was a red one. This is the total scenario. Now, how you're going to find the probability? The ones that are together to each other, you're going to put it together and then you're going to multiply them. This is the and one. This is the one that you're going to multiply, right? So, let's say she puts her hand inside the bag. She picks up a red ball. What is the probability of her picking up a red ball? 3/7, right? And then you multiply it with the probability of her picking up a green one. She put the red ball back into the bag. She picks up another one. And what is the probability that this time this ball is a green one? That would be a 4/7. Now you write or means a plus, right? And now let's reset the scenario and look at it this way. She puts her hand inside the bag and she picks up a green one this time. The first ball she picks up is a green one this time. You just go for 4/7 and then you multiply it with the probability of her picking up of a red one. That would be a 3/7. Right? This is going to be your answer. Okay, I'm not going to simplify it because I don't have a calculator on me right now. But I mean, this is going to be your answer. Just calculate it. I mean, this is something that you can do. I mean, come on, you're not a kid. And this is how you get yourself an answer. So this is how it works. Let's do the same thing now without replacement. Let's name her Sarah this time. Sarah picks up a ball, right? And then she doesn't replace it. Then picks up another one. How long has it been since I've been recording? I must check. It's been 20 minutes, okay? We're going to wrap this up quick, okay? Because this is the last one that I'm going to make today. Now look. So she picks up a ball, doesn't replace it, then picks up another ball. The event this time is going to be, let's call it Z, right? Now look. Again, we're just going to write the same thing. She picks up a green one and a red one. Now in this case, let's do it this way. Now again, how many scenarios do we have? She's either going to pick up the first. No, no, we know she's picking up two balls, right? One after the other. So again, the same number of scenarios. Either the very first ball she's going to pick up is going to be the red one, and the next one is going to be green, or the first one is going to be green and the next one is going to be red. Let me tell you one thing, why do the order, the arrangement matters? Because sometimes they're going to give you a specific arrangement. In that case, you won't have to find all of the possible arrangements, right? Why? Because they would give you one. So it depends upon what the question is asking you. You know what? Probability is less about formulas and more about common sense if you understand the gist of it all, right? Honestly, you know what? At the beginning, it does look kind of confusing, but the more you dive deep into examples and stuff, it's just going to feel easy. Honestly, I'm more excited to teach pure maths than statistics, but never mind, let's just be done with it. Okay? Now look, in this case, now before I do anything, let me tell you one thing. I'm not going to be changing colors, okay? Because you guys are not children and I'm not making a coloring book. You've got, you know what? Let's just use colors. Never mind. So you've got one, two, three. Okay. And the green ones are one, two, three, four. Okay. Let's say Amanda picks up a red one, right? She picks up a red one. How many do you have now? Now you've got one, two, three, four, five. Sorry, wait. One, two, three, four, five, six. Sorry. You've got six now. So previously, the total number of outcomes was 7, but now the total number of outcomes is 6. Why? Because this is without replacement. She is not putting it back into the bag. Now look, the reason why we put it back in the bag is because the denominator in here, there used to be this amazing thing in here. Yep, the laser pointer. Yeah, this one. I love this. The reason why we were putting it back in the bag is just so that our denominator can remain the same. Now look at here. She picks up a red ball. We find the probability. Now, let's say she didn't. She doesn't put it back into the bag. Now this 7, should it be 7, right? The total number of outcomes now should be reduced to a 6. This is the reason why we were putting it back into the bag. This is the difference between with replacement and without replacement. And with replacement, your denominator remains the same. Your denominator does not change, right? The denominator does not change. In without replacement, the denominator will change, right? And you would have to deal with it. The reason being, it's just a thing, right? So in here, let's say she picked up a red ball. Previously, the total number of outcomes was 7, right? But now that she has picked up the red ball, the total number of outcomes is now reduced to 6. It's reduced to 6. Want to know why? Because there are 1, 2, 3, 4, 5, 6. 6 balls left in there. Now when she picks up another ball, the probability, whatever the denominator is going to be, the denominator is going to be 6. Why? Because it's one ball lesser than the previous one, than the previous scenario, right? So let's write down the probability now. Sarah this time, she picks up a red ball. What is the probability of her picking up a red ball? 3. Why? Because there are 3 red balls in total. Divided by the total number of balls, currently that would be 7. Right? You multiply it with, now she did not put the red ball back into the bag. She didn't put it back. Right? Now she picks up another ball and that has to be green. The probability of she now picking up a green ball would be 4 over 6. This is how with and without replacement makes a difference. Okay? And then you add y because there's an or in here. And now look. 4 over 7. Why? Because now let's reset the scenario. Now again you've got, let me just write it here. Let me just make another one. Now look. So 4 over 7, right? Now she's going to pick up a green ball first. So a green ball is the one going outside going outside the bag. The green one is the one going outside the bag. So when she was picking up the green one, there were in total 7 balls. So 4 over 7 would be the answer, right? Now, without replacing the green ball back into the bag, she's going to pick up a red one. Right? And when she picks up a red one, the probability would be 3 over 6. Why? Because now you're never mind. I'm sorry. Now you're 1 ball less. You're 1 ball short of the previous scenario, right? This is how with and without replacement makes a difference. This is how every time you have yourself more than one condition inside a single event, how do you tackle them? How does or and make a difference? And how do you tackle them? And in the cases of and, how does or why does with and without replacement matters? You do not worry though, you won't have to figure it out on your own whether um you know the scenario or the event is taking place in a with replacement universe or a without replacement universe, because that is something you're always going to be told in the exam. It's something that is always mentioned. You're not going to be expected to figure it out for yourself, right? You just need to know this stuff. And again, I'm not going to write the answer here because I don't have a calculator on me right now. I can open one on my laptop just right now, but I'm lazy, okay? So what did we learn today in this one? You know what? I'm lazy. I'm not going to be repeating any of it. Just look through it yourself. We did some simple examples, right? Then we looked at in a single event, you can be given multiple conditions, and how you're going to tackle them depends how they're connected. Are they connected to each other using an or are they connected to each other using an and, right? The very first step is going to be similar for both the AND cases and the OR cases. You find the individual probabilities of the individual conditions. And once you're done finding them, then you have to tackle both of them. And that depends upon an or an AND. If the individual conditions are connected to each other using an or, then you add them together. If they're connected to each other using an and, then you're just going to multiply them. And again, when every time you see an and, then you're going to be told whether the entire thing is happening with replacement or without replacement. That was it for today's video. I know this lecture was longer. The stuff explained might have been a bit confusing, but I hope so it's not confusing when you finally reach here. Okay, I'm just going to write my sign just because I feel like it's 2:06 p.m. and inshallah ta'ala I'm going to meet you in the next class. Okay, that's it for today. Assalamu alaikum wa rahmatullahi wa barakatuh. See you in the next one.